Hi, this is Wes Simpson with another edition of the Summer Sessions on Media over IP, brought to you by Ames and the VSF. With me today is Andrew Starks, who is the Director of Product Management from Macnica Technologies. And he's going to be talking about NMOS, the API for IPMX. Welcome, Andrew.
Hey, how's it going, Wes?
Great. How about with you? How are things?
Well, I wish I could actually tell you that I'm at the beach right now, but if I was at the beach wearing my Macnica shirt like that, I'd be like the biggest nerd there. So it's going as well as it can be for being in the basement in front of a green screen.
There you go. There you go.
And I am excited to talk about IPMX.
Yeah, so I understand that your background includes some interesting activities in the
Yes.
Pro AV market.
Well, I have to tell you, the start of my career began in 7th grade in public education government access at a station called BEC TV.
Cool.
And I did everything from, we actually had a 4-channel instant replay controller made out of 4 Panasonic VHS decks that a guy named Rick Keeney made. And we made our own TV automation system off of Mac SE. And then we also made like an automated video bulletin board out of it.
Cool.
And then eventually I had my own TV show there. So that was my start. But then I had a company for 20 years in the Pro AV space and the broadcast space. And so for me, you know, live production, Pro AV, it was all the same soup, you know.
Cool, cool. Well,
Yeah.
let's get started. All right. So why don't you introduce your presentation?
Well, yeah. Well, I'm excited to talk about NMOS, and I like to remind people I used to say it's the API for SMPTE 2110, but now that we have a IPMX name and we're talking about the Pro AV market, it's really it's the API for IPMX, right? Everything that we want to do and interact with, every way we want to interact with the technology, we're going to do it using this API. But you know, when we were looking at this, and we were actually, if you think about it, Ames has been thinking about Pro AV for quite a while. And what we found is when we showed ST2110 to everybody, you know, the reaction was great, but it wasn't solving the problems they need. And what it really came down to is really 2 things. One thing, you know, and it kind of encompasses the other. One thing is that flexible trade-offs that people need. You know, they need to know that they can dial the quality and the bandwidth and the latency in the way that they need for the application. You know, it's easy to think, okay, Pro AV, that means cheaper, right? It means like,
Not
we're
always.
going to do, simple, cheaper, all that. There are times when they are doing productions. I mean, if you look at some of these mega churches, or you look at what they're doing in the medical device area, or, you know, very large public digital signage displays, that's all uncompressed. That's all redundant. It's all the things that we want in the broadcast industry. It's just in a different context.
Mm-hmm.
And the other sort of set of things people want is that HDMI experience, because if you think about what we went through in the broadcast world, right? We wanted to bring that SDI experience. And that was 2022, right? And it's the same way in Pro AV. They've got HDMI everywhere. It's not the technology they would have picked if they would have made it themselves, but it is the one that they go to by default because it's ubiquitous, right? So we have to support the things that HDMI does. Otherwise, you know, we're not going to be able to play in the sandbox while they translate from, you know, baseband stuff over to IP. So, you know, those were kind of the 2 big things that we found, and a great way to kind of illustrate it. If you kind of think, there's a lot of different use cases, right, that you can think of, but one place that, you know, we all miss right now probably is a stadium, right? And a stadium uses video, you know, everywhere you look. They've got it in broadcast, they've got it in the digital signage, they've got it in, you know, security, they've got it in the conference rooms. They're using video everywhere. And today, a new stadium gets built, there's very little baseband video running through that facility. They're doing it all with some form of streaming, right? And today, that means proprietary standards. Outside of SMPTE 2110, you know, doing the broadcast side of it, there really is no standard at all in the Pro AV world. What we have are kind of de facto standards, or what I like to call promiscuous license agreements, that basically allow people to build applications, but they don't allow people to build interoperable implementations of the standard. So you really don't have that kind of vetting process and that kind of I don't know, the kind of result that comes out of a standard, right? So now one thing that I like to emphasize with people a little bit is that this is not a new thing, right? I mean, Wes, you've been around SMPTE 2110. How many years has 2110 been
Oh, well,
available
I
and
mean, the
running?
standard came out in 2017, but we started working on it in 2015.
Yeah, right, right. And so all of the stuff here on this roadmap we're looking at, you can see has been around a long time, and it's been proven, battle tested, and simplified, and rethought so many times, and so that's really where we start. That's our foundation. And you look on the right hand side, you can see what we're really doing in that sort of middle column on the right is we're taking what is in SMPTE 2110 and we're constraining it. We're pulling it in and we're saying you got to support JPEG XS as a base codec. You've got to support an amount of like EDID. You got to be able to read monitor displays. Oh wait, actually, I'm sorry. That's a new development. I'm going to stop there. I'm going to say you got to support SMPTE 2010, JPEG XS, and the second thing you got to support is NMOS 04 and 5. Whereas in SMPTE, that's completely optional, right? You can have a SMPTE 2110 compliant system, that uses some proprietary API. Not so with IPMX. If you sell a device that does not have NMOS on it, that's not an IPMX device.
Oh, okay.
So we're really, because what we want is that experience, right? I plug this thing in here, I plug that thing in there, and I can see it, I can find it, I can play with it. So that was the thinking there. And then on the right-hand side, we get to some of the more interesting bits. We've got HTCP, which is that fabulous copy protection that everybody loves. We got to be able to support that, pass it through. An interesting thing on that one is that in the Pro AV industry today, you would be amazed at how many people that are technically kind of not compliant. The modus operandi is to take your HDMI video into the encoder, terminate the HTCP, then do encryption, hopefully, over the wire using some method you have, and then starting another HTTP link. It's basically you're running it as like two separate links. That technically is not legal. And so we actually had to go to the DHCP body, which, different organizations, and then they talk to Hollywood and they look over the proposal. We had to come up with a real solution to that they approve. And when we're done with this process, that's a huge benefit. Something that's not there right now. General purpose IO and USB, huge in the Pro AV industry. Actually, just huge in broadcast too. I mean, GPIO is a big topic around ISO 7 with NMOS. In the Pro AV market, it's all KVM, right? Keyboard, video, mouse, that ability to have a monitor here and a computer anywhere else in the facility. That's a big use case that really drives that requirement there. And then the other ones, audio channel mapping, that gets kind of into the weeds. We won't cover that, but IPv6 and security, those are, common things that people know about in the IT world. Security is not an afterthought with us. It's optional here only because we recognize that there are some ad hoc products or products that are meant for very simple use cases like home use or whatever, and security just might not be part of that. It's still an IPMX device. It just doesn't accept encrypted things. So, but not an option in terms of the standard for sure.
Did you want to talk about EDID?
Yeah, well, so that's a big departure. So, and this kind of gets into that flexibility I was talking about earlier. If you think about broadcast, what they're all about is reference quality. They want all the pixels that they've generated to end up in the bucket when the production's done, right? And in Pro AV, it's all about experience. It's all about giving them the actual experience intended by the author. And sometimes that means down-resing it for your display. Sometimes it means having the frame rate. Just whatever is needed to make sure that the display shows what both the viewer and the author intended. And so in that spirit, really EDID lines up real well with that. EDID is that ability for a display to say, I can support this color space, this resolution and frame rate. I have these many speakers. I've got this precise timing. There's a lot of information in EDID. And you'd be surprised at two things. One, how big of a problem EDID is in the Pro AV industry, because it was really designed for one monitor to talk to a VCR, right, or to a Blu-ray player, not for multicast, situations where you're streaming to a 4K monitor and then a 1080p monitor appears, right? And so in the Pro AV market, if you just kind of do like a little Googling and searching, you'll find lots of papers written on EDID, and they're not happy papers. So we're really looking at EDID. We're not just looking at EDID and thinking, okay, how can we squirt this through IP? We're really re-looking at this. We are architecting this with a goal of making EDID transparent through that API. So we want to make sure that people can get the raw EDID information, but we're also thinking about, okay, and in a multicast world, how do people want to deal with connections?
Mm-hmm.
You know, what does a dynamic connection look like when the network starts going wonky or what have you, right?
Okay.
So, but right now it really is about EDID. So let's take a look at the architecture. This is just a very simple high level view of it, but I wanted to bring this up because it highlights something that I think is really cool about the way this was done. And I think this might have been a lesson learned in the standards industry where they, I remember there was a certain file format that ended up being really big and ungangly to deal with. And this approach here with Senti has been really compartmentalized and really modularized, right? And you can see in the blue area there, that's where we're really talking about the transport side. That's that real-time side. And the NMOS side that's in that orange area there, again, it still shares that same compartmentalization. So we have ISO 4, which is the essence of the model, and it's how we understand what's on the network in terms of a model, and how we can actually make connections between different devices is covered by ISO 5. That's that subscribed part of it. Network control, that's a protocol that's still kind of being adopted, and that's more about how we can make switches perform in a more optimal way in the network. But one that's real important to IPMX is one called ISO 7. It's called events and tally. I just left the tally part out just for us. But what it really is a way to, events, man. That you need that in a video system. Stuff happens, and you need to be able to signal that. And that's what ISO 7 gives you. And if you think about EDID, right? I have an event happen. I have a monitor gets plugged in. I need to send what's called a hot plug detect signal over the wire. How am I going to get that done? How is my monitor going to say, I'm unplugged, I'm replugged in, and by the way, I've got new EDID information? That all can happen. That's the mechanism that we use as ISO 7 to get that done. And just to take a look at some of the other things, I'm not going to go into them too much, but you can see that we have other work in here related to identity and timing and the system model. There's just a lot of little details here that go into NMOS and are constantly being developed and evolved. And I wanted to show this just to show how much work goes into thinking about video systems and thinking about how they work and how to make them reliable and secure. And it's all open, and it's all part of a very collaborative process that brings in a lot of different perspectives and talents. And it's really exciting to watch it unfold. So I wanted to start with ISO 4 because that's, as I mentioned earlier, that's the model, right? So that's how we understand the system, and that's how the software that we build with these APIs is going to see it. What they did was they started with a very simple, what's called a microservices model. And what that means is they take a video system and they strip away all of the things that are related to the application of it. So for example, it doesn't matter if it's in a truck, it doesn't matter if it's in a facility, it's just a device. We call it a generic device, and we have sources and receivers and all these things that make it up. And then what we do is when we put it out in the field and we actually implement it, that's when we fill out the details of what the device can do. And with that information, we can put that into the registry, and then devices can be discovered and found by various software systems and reasoned about in a way that makes it meaningful for the user. And like I mentioned earlier, you wouldn't believe the amount of time that's gone into designing these devices, but when you look at them, it's actually, straight up human readable stuff. It's not nothing fancy about it. And that's kind of a curious thing about NMOS and SMPTE 2110 in general, is that in spite of their origin story, right? They're coming from the very top end of everything we do with TV. It all comes back to the simplest possible solution to the problem, because that's the only thing that works when you get up into that heady space of broadcast TV, right? Next, I wanted to cover discovery. And what's really cool about NMOS's discovery system, and this is actually what's got me really excited about using NMOS. So in the broadcast world, I know I've heard people talk about, should we have peer-to-peer mode or not? Because as you can guess, anybody with a big facility, they're going to have the ability, they're going to have a centralized registration server that's going to have all of the devices already kind of registered with it. And you can see that on the right here. That's called registration mode, and that's what ISO 4 has in it. There's also what's called peer-to-peer mode. And what's so cool about that for Pro AV is it just covers so many common use cases. You pull a device out, you've got your laptop on it, you want to be able to see it. You know, you don't want to have to set it up, or maybe you're at a school or something. You want to have a great out-of-box experience that allows you to actually just use the device, right? And you would think that in Pro AV that this has already happened because it's such a huge need for everybody. There's just so many ad hoc scenarios where they're not setting up a special network server to register everything with, but it's not there. That's not a very common thing at all. In fact, in Pro AV, it's a lot like in broadcast where you have to manually enter everything in like it's like 1996 or something. And we haven't heard of zero conf and all that. But for all the pretentiousness and craziness of the broadcast industry, they had the wisdom to make it as easy to find an NMOS device as it is to find your printer. So it's just a great fit for our application, and we're really excited to use that feature. And we talked about it a little bit earlier, but EDID is, again, a really exciting feature, and I'm really happy about the approach we're taking with it. We're using the existing technologies inside of NMOS and just extending them the way that they were designed to be extended, including we're adding what's called a control type that defines EDID, which then can act as a service that basically automates different decisions about how the connection should be done and what resolution should be supported and what to do if a late joiner on a multi-cast flow joins and it's not the right resolution. All those things that so far in the industry are handled kind of unevenly depending on which manufacturer you're going with. We're going to provide an interoperable way that is not only provides like what you need as far as the feature goes, but the approach we're taking is much more about a generic mechanism. So we're not trying to build up the end all be all do it this way EDID solution. What we want to do is provide the APIs and provide the mechanisms to allow Pro AV manufacturers to make behaviors that are both interoperable and flexible. Because you know, when you're dealing with digital signage, video walls and color matching and all this stuff, what the right answer is to what you should do when certain situations comes up is anyone's guess, and it's not ours to try to guess it. Next thing I really love about NMOS, and maybe I don't know, there's many reasons why I'm excited. Actually, this is maybe the third, but it's very strong reason. Super excited about it. All right, is the web friendliness of it. And again, 2020, you'd think that we would be one of about 8 different web-based APIs for video systems, but it's just not true. Most of the APIs out there, in fact, I am not aware of an API that that is RESTful, that uses straight JSON, HTTP to advertise and get content. Now, it's not to say that the other APIs out there aren't accessible, but I know that I can probably throw a rock and hit a web developer that could understand how the NMOS API works just by looking at the familiar JSON object files and the very strictly RESTful API that they've developed. So really, you know, at this day and age, it doesn't get any more accessible than that. And then finally, the thing I'm, you know, of course, the most excited about is the fact that it's an open standard. Now, as I mentioned earlier, am much more familiar with the Pro AV world than I am sort of how the broadcast world works or that history. But I'll tell you, in the Pro AV world, there is a lot of confusion around what a standard means. And that's something that I think it just always, if you know, I'm going to take this time to just take a second to say that one of the things that because I'm new, that I really began to appreciate firsthand was the process, right? We all complain about how long it takes to make these standards, and we don't appreciate all of the great ideas that end up turning out to be crap. And we have to redo them, and we have to go again, and we have to rebuild, and we have to get it right. And there's no place you can do that like a standards committee. You can't get that done inside your company because once it works, you want to ship it. And then you've got a bunch of customers that have it. And then you've got to support them and that, you know, and that kind of stuff can happen in a standards committee or a standards body, but we do everything we can to make sure that it doesn't happen that way. And the way we do that is through interops, multi-vendor implementations, testing, redoing it until it's right. And that I just haven't seen that kind of rigor in a in another process before. And the other side of it that's just equally important is even if something's free, if it's not open, if you can't build anything you want from it, it's not a standard, and it's not really open, right? If I can't make an FPGA implementation, if I can't make my own implementation of the API, it's not open, and it doesn't have all the perspectives and all of the vetting that you would get with a truly open standard. And I think that most people, they're not going to pick up one box and pick up another and say, oh, well, this one's open, but this one has better quality, I'm going to go with the open one. Some do. That's not always the case. But I will say this, that's interesting that I found, is that when I've looked at, and I think what other people too have looked at the technology choices that that these standards bodies have selected, what you find is that they've selected the highest quality, best option, right? I mean, take JPEG XS, for example. There are codecs that are even more efficient than it, right? There are codecs that can compress even lower. There are codecs that have relatively the same latency, but there's no codec out there that I'm aware of that has that balance of power efficiency, implementation efficiency, and latency, and everything that goes in to being a viable, best choice solution for something that's a transport, right? You don't want something that is burning, 4 or 10 watts of power, just to get 1080p video over the network, but has great video quality. It doesn't work in transport when you have to scale it so high, right? So it's examples like that, picking the right codec that has the right balance, picking the right technologies that are simple, that comes out of a standard process just because of the way a bunch of engineers work when they work to make things simple. And the results kind of speak for themselves. I mean, we've re-looked at this from every direction, and when we consider our ability to be flexible with timing, to use JPEG XS, we find that 172110 suite of standards and the NMOS API together create a very high performance system for any application. And it comes down really to that one clean API that gives us a nice universal interface to really get back to a space where we were before SDI and HDMI sort of had a divorce, right? We used to all just play with video. And I remember back when I was at my cable access station I mentioned earlier, right? I had composite video. It wasn't as cool as your component video, but it was composite, and I could go from component to composite pretty easily, and I could use broadcast gear, or they could use my stuff pretty easily. Nowadays with HDMI and SDI, that is still kind of the case with converter boxes, but it's not nearly like it was. And if we can, decide to go to the IP world and ditch the converter boxes and decide to innovate more at the application level where our customers find value, and leave the plumbing to the standards committees, like what we're doing here, I think we're going to have an enormous amount of growth in the Pro AV industry. I think there's going to be an amazing amount of creativity and interoperability. And I'm also really excited about the idea of interoperating between broadcast and Pro AV, and even like consumer things like that, where we can have an API and have standards where interoperability and managing latency and having video systems that work cleanly together without a lot of complexity, that's really the future that we're kind of reaching for.
So thank you very much. That was an interesting presentation. So SMPTE specs are used to build a lot of really complex networks, like the Super Bowl and the Academy Awards and things like that. Is that technology really going to be applicable when we scale it down to work in the Pro AV market?
That's a great question. Actually, it might be my favorite one because I get it all the time. People are, they want to say, well, SMPTE has its place and everything, and they kind of pigeonhole it into, they kind of equate it with how it's used, right? And when, if I'm a broadcaster, I'm dialing that up to 11. I want absolutely the best timing. I don't want to sacrifice anything from my SDI system, and so, in that sense, no, it's a terrible technology. And we found that when we first came there, where's my EDID? Where's my, all the features that are missing? But if we were to go back and clean sheet this, we'd end up in the same spot, because SMPTE can't afford waste. They can't afford an inefficient codec, and they can't afford to reinvent their own, packet protocols and things like that, because they're not going to get switch manufacturers to go along with it, right? So what they did was exactly what anybody else would do. And what they're bringing to the table is really that rich set of interoperability, the rich feature set that really isn't in Pro AV right now.
Mm-hmm.
You can have box A do KVM, but you can't have box A do KVM with box B. And
right.
In the sense that do we need to have all the power that SMPTE 2110 has? Sometimes, absolutely. And that's another point I kind of want to make in that regard, is that it's one thing to say, hey, I don't need all that power, I can go ahead and get this lower end thing, right? Well, SMPTE offers that. SMPTE gives you the ability to use compression to eschew PTP timing and have asynchronous sources. There's nothing wrong with it. It'll work, right? It'll work great. It'll work as you expect it to. But then for those applications, as a Pro AV manufacturer, you get that customer that come in and they say, hey, we've got a showcase installation here that's going to intermix with our broadcast production switcher that we use for our CEO's addresses, and we want it to show up on our digital signage system, but we need it to be within whatever latency, and you're using something else. Now all of a sudden your guys have got to get smart about SMPTE 2110, and they got to get smart about a bunch of technology they've never seen before, and you got to buy all the converter boxes to make it work. And it's not simple anymore, right? And being able to have that freedom to go to a customer and say, I can give you 1 gig, I can give you 2.5, 5, 10, 25, 100 gig, whatever it is you need, I can give it to you. And my people are experts on that because it's the same API, it's just video, and we just pick the right technology for the application without having to learn, a potpourri of plumbing options. And I think that's, because SMPTE knows how to science video out, they do a great job of it. And now that they're turning their attention on the application that Pro AV people care about, it's off to the races.
So one of the things that I think is really cool about some of the things that the AMWA and SMPTE are doing is automatic registration. That seems like something that is really going to be of a benefit to the market. I mean, how do people do registration today? How do you put a new device in the network?
It's funny. It seems like because video has this real-time element in it, we have to make it hard for some reason. We've got to make it like I gotta plug it in directly into the thing through the serial port, and I gotta type in the serial number into it and register with the manufacturer, and that's how it is now. It's like you're in Windows 98 or something, and you got to type in your, and it's just part of it's momentum. Part of it is a desire to have your customer, to hold on to them, right? And I totally understand that. As a manufacturer, if you can have a captive audience, you want to have that. But the thing is, you can get a certain amount of business that way, but to really get that broader business, being open is the key. And part of that is just being unafraid to have your video devices discovered by anybody's software, just like your printer is, right? Your Apple phone or your Android phone picks up your HP printer just fine. And that's just not a concept that's real prevalent in Pro AV right now. It's not a mindset that's prevalent. So they don't have automatic registration in that way. I mean, if it is automatic, it's automatic with your own box, right, or your own manufacturer. And but quite honestly, I've actually more seen just the manual registration. And it's funny. I wish that feature on NMOS was more in people's minds, because that would do a lot to sort of make them associate it with easy, sort of blue jeans, right? I can just, you mean it doesn't ask anything of me? And, and the device that we're making, we're using just the NMOS facilities to make it so that I can type in Matnica encoder .local return, and my web browser pops up with a web interface. That's cool. Without anything else other than what NMOS gives us, right? So and now our anybody that's our manufacturer, they have the same benefit. Nobody has to reinvent that. It just works, right?
Great. Well, thank you very much for joining us today. This is really interesting. I can tell you have a lot of passion about this topic. So
yeah, I've heard that before.
well, thanks. So that went really well. Glad you could spend some time with us. I hope you have some good weather coming your way, not just in your basement.
Yes, well, It's been like 94 degrees lately.
Ooh.
Today it's gonna cool out. It's pretty nice. So,
All right. Well,
absolutely.
yeah. Let's hope for cooler times and the ability to do a little travel coming up in the near future, I guess, huh?
Absolutely.
All right. Well, thanks so much, Andrew.
Yep. Thank you, Wes.